Hi, sophomores. I did not make a video during class today, so I'm making one just separately for you guys. And actually, it'll work out well because I can kind of tell you what you need to do for having missed class today. So what I encourage you to do is first, I have posted the homework notes or the homework answers on OneNote. So I would encourage you to look over those. Again, here they are. So go to your homework answers and look at the worksheet that was due today. And again, show me that worksheet Friday, but you can check your answers a little bit ahead of time. And then I encourage you to do this review. So this first page of the notes is a whiteboard review of everything we've done so far, one of each problem. So we have a subtraction, a multiplication, and a division. So I'd like you to stop the video right now and go to those notes and try to work that out. And then come back and check it, okay? Because we spent a large majority of the time today actually reviewing the process. So stop it now and do those notes and then come back. I'm going to go ahead and work them out and tell you my steps, but hopefully, again, this is more should be checking what you did. So on subtraction, again, remember you have to find a common denominator. So the first thing you want to do is factor out both denominators, and this becomes x minus 2, x minus 1. So to build our common denominator, we're going to have to use both factors, x minus 2 and x minus 1. And then we need to rewrite each fraction with our new denominator. So to rewrite this fraction to have this denominator, we have to multiply by x minus 2. So I distribute that x minus 2, and I get x squared minus 2x. To build this fraction with that denominator, well, it already has that denominator, so I just simply bring over that 2x minus 1. I'm going to write it in parentheses, so that reminds me that when I subtract, I have to distribute that negative. So now my answer will have the denominator x minus 2, x minus 1, and now I simply have to perform the subtraction. So x squared comes down, minus 2x gives me minus 4x, and minus a negative 1 gives me positive 1. So that's my final answer. I would want to look at it and make sure that I couldn't factor the numerator to cancel anything out, but it can't be factored because nothing multiplies to 1 and adds to negative 4. So we're finished. Now on multiplying, again, remember multiplying we like a little bit better. It's a little bit easier because all you need to do is factor everything and then cancel top and bottom. So we look at this one, x squared minus 4 factors to x minus 2, x plus 2. X squared minus 1 factors to x minus 1, x plus 1. X plus 1 is itself a factor. It can't be simplified, so we leave it. X squared plus 2x, I can take out a GCF, and it factors to x times x plus 2. Now I just cancel anything on the top with anything on the bottom. So my x plus 2's cancel, my x plus 1's cancel, and that's it. Now I gather what we have left, and we have an x minus 2 on the top and an x times x minus 1 on the bottom. Nothing else can cancel, so that's our final answer. Last one is division, and again, division is just like multiplication in the fact that you have to factor everything, but you also have to change it to multiplication and flip. So the first term factors to, so this one factors to x minus 2, x minus 3, and the bottom doesn't factor, right? It's just a single, x to the third. Second term, I'll change it to multiplication and flip it. So 4x squared goes on top, and it's just a single term, or single, right? The top factors to x plus 5, x minus 2. Now I cancel. My x minus 2's cancel, and these are singles. So think about this as 4 times x squared. So this x squared cancels with this, or simplifies with this x to the third down below, and leaves me just 1x. So my final answer is 4 times x minus 3 over x plus 5. It would not be wrong if you went ahead and distributed, to make it 4x minus 12 over x squared plus 5x, but I would actually rather you leave it like this because that shows that nothing more can cancel. Okay, so that's our warm-up. Again, hopefully you tried that out yourself and then use my explanation just to check your answers, okay? Now, the only new stuff we learned today, so we skipped the next page because it's a warm-up that I feel like it's more complicated than the actual problems, and we went right to the third page. So simplifying complex fractions, and we're just going to work through a couple of these. Again, we've worked through these on our division page a couple days ago, but there's just a little trick on some of these. So, looking at this problem, again, I can think about this as 2 over x divided by 3 over y. So when I'm dividing fractions, again, I keep the first term the same, change it to multiplication, and flip the second. So if I do that for this problem, I get 2 over x times y over 3. Then I just multiply across, and I get 2 over y, 2y over 3x. Okay? Now look at this next one. I've got 2 over x plus y, and that x plus y, even though it's a plus sign, that really is not an addition problem, right? It's just a denominator that happens to be a factor family. So my top fraction is 2 over x plus y. My second fraction, I need it to be a fraction, so I'm going to make it 5 over 1. So now, if I look at this problem, it's 2 over x plus y divided by 5 over 1, which again can be written as 2 over x plus y times 1 over 5. Again, I'm changing it to multiplication and flipping the bottom. Then I multiply across, and I get 2 over 5 times x plus y. Okay, and again, if you wanted to distribute that, you could, but I kind of recommend not distributing that. Okay? Okay, the last problem is where the little tricky part comes in. So if we look at this, 3 over 2 is a good fraction, but 1 plus x over y is not actually a fraction. It's actually an addition problem. So before we can do the division piece of this, we have to make this 1 plus x over y an actual fraction. So in order to do that, we need to add these two fractions with a common denominator. Again, if we think about it like this, our common denominator will be y. X over y is already a good fraction with y as a denominator, so we're set. The 1 over 1, in order to make it have a denominator of y, we have to multiply it by y. So 1 over 1 becomes y over y. Then if we do the addition, that fraction becomes x plus y, or y plus x over y. Now we can finish the problem by taking 3 halves divided by that answer. And that looks like 3 over 2 divided by y plus x over y. We can rewrite that as 3 over 2 times y over y plus x. And that becomes 3y over 2 times y plus x. There we go. Okay? So again, it's just division, but you just have to make sure you have two fractions first. Okay? Now, the only other problem we did in class is this next one. So don't worry about the last two. We did not do those. They're a little bit more complicated, and you won't be responsible for those. So don't worry about those two. But let's look up here. Okay, so if we look at this one, again, our bottom fraction's good. 1 over xy, we got that. This one we need to first combine to make it one fraction. So we need to add them together with a common denominator. So between x and y, our common denominator will be xy, right? X times y. So to rewrite 2 over x as something over xy, we have to multiply top and bottom by y. So this becomes 2y over xy. To rewrite 3 over y as something over xy, we have to multiply by x. So this becomes 3x over xy. When we actually do the addition, again, our final answer is over xy, and it becomes 2y plus 3x over xy. And now all of that gets divided by 1 over xy. So now, to finish the problem, we take the bottom, we change it to multiplication, and take the reciprocal of the bottom, so that becomes xy over 1. And we multiply, and again, when we multiply, we can simplify by cross-canceling. So the xy's actually end up canceling out, and our final answer is 2y plus 3x. Okay? Okay, so that's all we learned today, and the rest of the time we practiced and we worked on our worksheet. So take a look at the worksheet that's posted on SchoolFusion. On the front, which is the complex fractions like we just did, I've only assigned numbers 15, 18, and 21. And don't worry about the rest of them. They're more difficult to do. You don't need to. The second one, on the back, I've assigned problems 1, 3, 5, and 8. And that is just a review of addition and subtraction of rational expressions. So do your best. I highly encourage you to get some help from either me or Mr. Armstrong if you're having problems with these. We'll go over them in class on Friday. We're learning one more new thing, and then next week we will review and test on Thursday. So anyway, it's really important that you keep up, and if you're having issues or need to review your factoring, then you may need to get some assistance. So, okay, I hope you enjoyed ACTS, and I will see you Friday. Bye.